వర్షం పడితేనే మాకు మళ్ళీ ఏమైనా పంటలు కానీ ఏది కానీ మాకు పంటలు పండేది. వర్షం పడకుండా ఏం పంటలు వచ్చేది లేకుండే.
This Telangana is mainly Deccan Plateau. The only water source only Godavari river.
Water is available in our Godavari, but they are at lower levels. Most of the areas are existing at higher levels. Most of the areas are not covered with the irrigation facilities. Farmers are needed the water. Kaleswaram project is a world biggest lift irrigation project, and it is a multi-purpose project.
Having seen the project site, we were little bit worried about at this scenario, at this place, we could do it. This size of project is practically possible or not.
Supplying the world highest capacity pump 139 megawatt. Never have been such a huge capacity pump elsewhere being installed or commissioned.
సర్ఫేస్ మీద నుంచి 100 మీటర్స్ బిలో ఉన్నాం మనం. సో హ్యూమిడిటీ ఎక్కువ, ఇది ఒక మెయిన్ ఛాలెంజింగ్.
It's a teamwork amongst all the various system suppliers.
As a team, if we work, definitely we can achieve any type of job.
In the farmlands of Telangana in southern India, life is hard. Farmers put in back-breaking labor from dawn to dusk, but the returns are not always guaranteed.
వర్షం పడితేనే మాకు మళ్ళీ ఏమైనా పంటలు కానీ ఏది కానీ మాకు పంటలు పండేది. వర్షం పడకుండా ఏం పంటలు వచ్చేది లేకుండే. అట్లా ఆడ తప్పు వేసుకుని మాకు ఇబ్బంది అలా వేసుకుంది. అట్లా ఖర్చులు అది ఈ ప్రకారం కూడా ఇట్లా నడుస్తూ ఉన్నది. వర్షాధారం మీద ఆధారపడి పత్తి మక్క అవి పెట్టినప్పుడు సరైన టైంలో వర్షాలు పడక బాగా కరువు వచ్చేసి మాకు పంటలు రాక నష్టపోయి భూములను బీడు పెట్టుకోవడం జరుగుతుంది సార్. 4 బోర్లు వేసినాం ఇప్పటి వరకు, చుక్క నీరు లేదు కాబట్టి మళ్ళీ బీడు ఉంచడం జరుగుతుంది సార్.
Telangana is notorious for its water woes. Frequent droughts plague the region. The river Godavari runs straight across this land, but its waters don't reach the farms that need it the most, giving rise to an irrigation crisis that's loomed for decades.
Though we have two major rivers, they are in the name of Krishna and Godavari. So a lot of water is available in our Godavari, even in Krishna also, but they are at lower levels. Most of the areas are existing at higher levels.
But in this dismal landscape, there is still hope. In the early 2000s, plans were initiated to tap the monsoon floodwaters of Pranahita, a river flowing from the western state of Maharashtra. A project was conceived. It would take the floodwaters south towards agricultural lands. But in 2010, there came a roadblock that put a question mark on the project.
One important point is insufficient storage. Second is insufficient flows available. So the requirement of water is not there.
Planners needed to find an alternate site where the river waters were in surplus. Survey teams descended along the riverbanks of Godavari and Telangana. They used cutting-edge technologies like LiDAR that use laser illumination and sophisticated sensors to aerially survey the riverbank. It provided invaluable information about subsurface topography and river volumes at various points. And it did so in a remarkably short time.
Conducting survey is a big challenge. For irrigation purpose, nobody has done this survey, and this survey saved about 6 years, which we have done in 6 months.
With technology helping to speed up the process, planners could now begin turning their vision into reality. Their search led them to Kaleswaram. Kaleswaram, on the banks of the river Godavari, is sacred ground, home to a famous temple devoted to the Hindu god Shiva. It is believed that no prayer goes unanswered here. And it's not the only blessing Kaleswaram has to offer. Here lies the confluence of two mighty rivers, the Godavari and Pranahita. In the monsoon season, waters swell in both the rivers. When they unite, the bounty overflows. What if these floodwaters could be redirected to address Telangana's water woes? With renewed energy and fresh outlook, the government of Telangana redesigned the project into the Kaleswaram Lift Irrigation Scheme, or Kaleswaram Project. Medigada, a small village on the banks of the Godavari, was chosen as a starting location for Link 1, the very first phase of the Kaleswaram project.
After becoming a new state, Telangana really wanted to have water. We have the allocation of 950 TMC of water from out of the river Godavari. So to utilize the full potential of that allocation, I thought it is the best place to construct a barrage here, pump house here.
The Kaleswaram project was slated to make a huge splash. 169 TMC of water would reach 37 lakh acres, irrigating an additional 18.25 lakh acres of new farmland. It would replenish groundwater and provide 30 TMC drinking water. 13 districts of Telangana would reap the benefits. How could a single river source possibly be diverted across such a huge expanse, especially one as hilly, craggy, and cratered as Telangana? By defying gravity through the science of lift irrigation. Where the natural river can't flow, most often because of an elevation or rise in topography, artificial machines like pumps are needed to drive the water up. But to lift a river, that requires not just any ordinary pumps, but the largest pumps and pump houses in the world.
In the first lift near Kaleswaram,
Megha Engineering and Infrastructures Limited, or MEIL, is one of the stakeholders chosen to build a majority of pump houses in the Kaleswaram project. When it comes to massive infrastructure, this team has a combined experience of over 3 decades. But nothing they've done has been so mega in scale or scope.
Volume-wise, it's a big project. For that, actually, first we concentrated more on designing part. It's a very critical, one of the largest project in the world. We concentrated more on design part.
key members went for a project visit. Having seen the project site, we were a little bit worried about in that this scenario at this place we could this size of project is practically is possible or not. We have internally reviewed it, but the advantage is that we have in-house supporting groups.
The design challenge is a tall order, literally. The Kaleswaram project must lift water between two elevations, Kaleswaram at 90 meters above sea level and the Konda Pachama Sagar Reservoir at 618 meters above sea level, making for a total elevation of nearly 528 meters. The scheme will operate only in 3 to 4 monsoon months, lifting up to 2 TMC of water a day. To lift water at regular intervals, the Kaleswaram project will be an elaborate network across a total distance of nearly 500 kilometers, with 28 packages or construction clusters consolidated into 7 links, with 20 mega-volume water lifts, 22 pump houses, and 20 reservoirs, which will all be connected through over 1,850 kilometers of pipelines, canals, and tunnels. That's more than the distance between Kaleswaram and India's national capital, New Delhi. Blueprints come together. But drafting designs is one thing. Building it on location is something else altogether. And there's another catch. The team has 24 months to complete the job.
As a team, if we work, definitely we can achieve any type of job, any quantum of job, whatever the criticality, definitely we'll achieve. I'll tell always my team members, for every problem there is a solution. How fast you can find out the solution, then based on that we can achieve anything. Not only in projects, anything in the life also.
The heat is on. Construction begins on Link 1 of the Kaleswaram project. The barrage at Medigada. This is where the floodwaters of Godavari will first be introduced into the lift irrigation mega project. It stretches across 1.62 kilometers with 85 gates. It has the capacity for over 16 TMC of water as live storage. That means without building a reservoir or submerging the riverbank. And that's not all. This megastructure has broken records for the sheer amount of materials used. 18,50,000 cubic meters of concrete, enough to build 7 Burj Khalifas. 24 kilometers upstream from the Medigada barrage is the site for the first pump house in the Kaleswaram project design. In this phase of construction, 11 40-megawatt pumps will be installed, lifting 2 TMC water each day, enough to fill more than 2 lakhs Olympic-sized swimming pools. The pump house is getting ready to receive its pumps, each one a mega monument to scale and engineering. After all, these pumps must literally lift a river. In order to execute the Kaleswaram project's Made in India designs, an international consortium was carefully selected. Expert engineers and manufacturers from across the globe took on different components of the massive undertaking. But when it came to the biggest and most powerful pumps, the mega project turned to India's finest engineers. Bharat Heavy Electricals Limited, or BHEL, has pride of place as the only Indian public sector undertaking handpicked to make the largest pumps and motors used in the Kaleswaram project, destined for underground pump houses at a site known as Package 8. They will be among the largest of their kind anywhere in the world.
The only thought that came to my mind is that the size is quite large, because earlier we have done lift irrigation pumps having capacity of around 30 megawatt or so, but this time around the call was different. The motor along with the pump that was required to be designed was of the order of 139 megawatt. So that was quite a jump.
139 megawatt motor-driven pumps. To put it in perspective, imagine a typical water pump at home, which runs at only half a kilowatt. BHEL will have to build one that is nearly 300,000 times more powerful.
But the section here, water is supposed to come from.
Building at this scale means one simply can't go from paper to manufacturing. The design must be tested in the virtual world.
If it's not in sync, then continuously flow will.
But even if it works on a computer, it doesn't mean the design is final.
Yeah, velocity in this direction is higher than at the other location.
Inside the BHEL's state-of-the-art hydrology testing lab, it's time to check if the computer model will work in the real world.
Since this design does not have a reference, it's not a proven design. So what we do is make a small scale model and experimentally test it.
After nearly a year and a half of designing, testing and tweaking, the small-scale model is ready to go giant on the shop floor. Which means that back in Telangana, things need to ramp up. As the teams get ready to do the impossible, at the nth hour, a crucial change is made to the schedule. The deadline has been moved up on Link 1 of the Kaleswaram project. 24 months has shrunk to 18 months. But is that enough time to build the world's largest lift irrigation scheme? It's crunch time.
Whether we can able to do with 18 months or not, yes, it is a bit of challenge.
There's no luxury to build one site at a time. Work must proceed simultaneously at nearly all 7 links in the mega chain of the Kaleswaram project, including every barrage and pump house at Medigada, Anaram, and Sundila, all the way down to the project's largest underground pump house, known simply as Package 8. But compressing timelines cannot come at the expense of what matters the most: safety.
In the beginning of this project, we have planned for certain 24 months. Then, of course, compressed to the 18 months. During the compression stage, we internally discussed that we have to give a first important role to the safety.
To meet the new deadline, fresh batches of workers pour in at every site, from unskilled labor to engineers and managers.
There are 2 types of challenges we may face in this mobilization of the teams. Number 1 is skilled manpower, sourcing of the skilled manpower across the India who do the basic civil works. Then second important thing is getting the knowledgeable or technically sound engineers to supervise the manpower.
60,000 skilled labor have been engaged on our Kaleswaram project, right from link 1 to link 7, which involved all the states. So all the states contributed to the construction of this project.
As teams get ready to jump in Bhopal, the mega pumps of Kaleswaram project are taking shape. The manufacturing shop floor of BHEL is buzzing with activity. They're building pumps for the Package 8 site. At 139 megawatt capacity, these are the largest irrigation pumps ever to be built at BHEL or the world.
Very naturally, since it's a 100 plus megawatt capacity pumps, so the components had to be pretty large. Handling them itself was a challenge. We had to make sure they had to be handled safely as well as without any damage to the component itself. And since these are pumps, accuracies demanded were pretty high. So that is where this state-of-the-art machine shop came to our aid.
The can-do spirit is infectious. Back at the Medigada site, the pump house is coming to life. Backwaters from the Godavari are redirected from the Medigada barrage to this point. They spill into the approach canal, which is the river's entry point into the pump house. Here, gravity will push massive volumes of water into the forebay area. Controlled by head regulators, it will collect in a sloped catchment area. At the foot of the forebay area are the entry gates of the pump house. 17 gates leading down into 17 pumps. As water gushes through, silt traps filter out sediment particles, rocks and pollutants to protect the delicate machines within. Unlike typical hydropower pumps that start rotating without water, slowly taking it in as they gain momentum, these pumps will begin turning only after a full load volume is introduced. This feat makes them weightlifting champions of the water world.
I don't think it is the similar 40 megawatt single with a load pumping system available in the world, definitely. That is the uniqueness of this Kannepalli, that is a Medigada project.
The stakes are high. Attention to every detail must be even higher. Medigada pump house site in charge, Veno Madhov, is on his daily visit. He is the man on the ground and the leader of his troops.
You know that so many projects will take so many years to complete, but here we have planned to complete this project within 2 years. So you have seen this is hardly about 7 to 8 months of progress.
Steering this ship is a lot like coordinating a mini UN. Nearly 10 national and 5 international companies are collaborating on the Kaleswaram project. Nationalities, languages, and work styles might differ wildly, but they must come together efficiently and fast.
My name is Winfried Bosch. My job here is supervise spiral casing assembly and installation, and also machine assembly and installation.
It's not just the deadline that turns up the heat. Temperatures on the job site can reach up to 48 degrees Celsius in the summer. For our friends from cooler climates, it's quite literally being in the hot seat.
I think it's okay. People work very, very fast and also very good. And just the weather condition make us a big problem. We work day and night shift, and I think we can keep our time according to schedule.
No matter what, the schedule is king. Because every project is a vital link in the larger water chain of the Kaleswaram project. Once water is released from the Medigada pump house, it will be lifted straight up to heights of 40 meters, or nearly 130 feet, falling into massive delivery canal. Then it will begin its long journey inland, conveyed through gravity canals, pipelines and tunnels. This is precious cargo, liquid gold that farmers are anxiously waiting for. Not a single drop must be spilled. But when you're carrying nearly 56 billion liters of water each day, no ordinary pipes will do. For the last 8 months, specialized teams have been fabricating giant pipes out of massive sheets of steel. The sheets are cut, aligned and welded into 6-meter-long pipes, nearly 10.5 meters in diameter.
In Medegata pump house, we have to install 11 numbers of pumps, and each pump having 2 lines. One line is of 1 kilometer. So we have to fabricate here 22 kilometers of MS pipeline.
At every stage of the process, fabrication unit head Suresh Sawant is there, sweeping every inch of the pipe section, looking for the smallest cracks and imperfections. Besides visual tests, each joint undergoes radiographic tests, where X-rays or gamma rays check the soundness of internal structures. Then, they undergo hydro testing, where they're put under immense water pressure.
Quality is very important because this pipeline is going underground and leak should not be there. Ultrasonic testing is a non-destructive testing basically. और उसके अंदर क्या metal defects, if any kind of metal defects are there, we can find it out with the ultrasonic testing. अगर वो welding joint वहाँ से weak रहेगा तो in future वो वहाँ से लीकेज चालू हो जाएगा और धीरे धीरे वो बढ़ेगा और वो joint crack हो जाएगा. तो we don't want any kind of mistakes. So और हम यहाँ पर 100% जो भी field joints है उसको 100% ultrasonic testing करते हैं.
Only when every millimeter is deemed okay are the pipes put into commission. After all, they shoulder a mammoth responsibility, lifting 2 TMC of river water, up nearly 130 feet to the delivery canal, every single day. From here, water will flow on sheer gravity alone through the downward gradients of Telangana, for nearly 15 kilometers of gravity canals, all the way to their next pit stop. The Anaram Barrage on Godavari River. This is the threshold to one of the most extraordinary engineering feats of the Kaleswaram project. Godavari water lifted from the Medigada pump house has traveled upstream to Anaram. Here, the barrage stops and holds the water. Levels rise until the river begins to flow in reverse against the natural current of the Godavari. One might stop and wonder, how can water flow in the opposite direction? Wouldn't the natural flow of the Godavari resist it? Herein lies the beauty of the Kaleswaram project. Planners have identified stretches of the river that have dried out and then designed a way to revive it.
When the water is coming by lift and going into the barrage, so it's creating a level difference. So that making to run the water in reverse direction by way of increasing the level difference from one point to another point. It's a great thought. It's saving a lot of area under submergence. We have not at all taken a single acre for the submergence of the storage. It's a great experience for us and great thinking. This is very economical. We are making the river without excavation of any canal. You rightly said, river has become a canal and it is giving water to us.
With the Kaleswaram project reintroducing water into the previously dry riverbed, everything comes alive.
First advantage is having the balanced rivers in the Godavari and keeping Godavari with almost water, full of water into Godavari for a length of nearly 60 to 70 kilometers. Throughout the 60 kilometers of the Godavari, a lot of groundwater rechargement will be there.
Apart from that, it will be helping us to grow fish. So fisheries is the main, advantage out of these barrages and the other water bodies.
From the Anaram Barrage, the waters flow in reverse towards the unarmed pump house. Here it is lifted again and sent toward its next destination along the Godavari, the Sundilla Barrage. At Sundilla Barrage, the same cycle repeats itself as water flows in reverse and enters the Sundilla pump house. From here, the Godavari river water gets yet another lift to reach its final destination along Link 1, the Sripada Lumpali Reservoir. From the time it first entered the Kaleswaram project until this point, the river has been lifted to a skyscraping height of 148 meters. But the best is yet to come, because the river is about to take a turn southwards, unearthing the most record-breaking features of the Kaleswaram lift irrigation scheme. As we move south, one of the toughest stretches comes up. From here, the topography becomes so rocky, it's virtually impossible to lift the river.
If you start taking the open canal system, nearly 100 schemes we have to provide. If you go above the ground with open canal system, lot of CM and civil works, every roads, canals, we have to connect with so many structures, maintenance will be there, cover problems will be there, and pilferages will be there, unauthorized usage will be there.
Above ground lift pumps are not an option in this region. There's just one way left to go: underground. The only trouble is, underground, the rules of construction completely change.
This is one of the challenging package which we have in the total entire Kaleswaram scheme. Underground pump houses, the selection of the place is very, very important. When you go deep and deep, you should have a solid rock strata. If you do not have a solid rock strata, the problem what you have to encounter it, once during the execution there may be a lot of unexpected collapses also.
Before construction began, detailed geological tests were conducted over and underground. It revealed something wonderful. The same volcanic geology that was an obstacle to construction above ground, down below, was a blessing.
Good rock is available underneath of our ground at our required level. So that made us, go for underground tunnels. All are going through good granite. Therefore, our, requirement is made easy.
Welcome to one of the largest pump houses in the world, spanning more than 8,000 square meters. Almost 470 feet under the ground. This is Package 8. A fantastical other world beneath the surface of the earth. In this underground city, extraordinary engineering is at play. An earth-shaking 23 lakhs cubic meters of soil and rock has been excavated to build this subterranean pump house.
యాక్చువల్గా దీన్ని మనం తీసిన దానంతా మక్క అంటుంటాము. ఈ మక్కని మనం ఏం చేసినామంటే బయట డంప్ యార్డ్లో డంప్ చేసిన తర్వాత దీన్ని మళ్ళీ స్టోన్ క్రషర్స్ ద్వారా క్రష్ చేసి ఇదే అగ్రిగేట్ని మళ్ళీ కాంక్రీట్కి మనం యూజ్ చేసుకున్నాం. సో దీనివల్ల మనకి మళ్ళీ కొంత బెనిఫిట్ వచ్చింది. బయట ఫర్దర్ ఎన్విరాన్మెంటల్ డ్యామేజ్ కాకుండా ఇదే మక్కని మనం వాడుకుంటూ అగ్రిగేట్ రూపంలో కాంక్రీట్ వేయగలిగాం.
This towering size points to its lofty task. The underground pump house must receive 2 TMC of the Godavari's waters that have traveled through twin tunnels. As it thunders towards the pump house, it will crash into giant storage towers known as surge pools. Surge pools are the buffer of underground pump houses. They allow water to gush up, releasing excess energy and protecting the pumps from damage. They also double up as storage containers that regulate intake to the pumps. Surge pools are common in all underground hydro projects, but at the Kaleswaram project, nothing is done in small measure.
ఆల్ టుగెదర్ మన దగ్గర 3 crore లీటర్ ఆఫ్ వాటర్ ని మనం స్టాక్ చేస్తాం దీంట్లో. అదే సర్జిపూల్ స్టాక్ ఉంటే ఆ స్టాక్ ఎంత కావాలో అంత తీసుకుని మిగతా ఇట్ కెన్ బ్యాలెన్సింగ్ ద లెవెల్. ఆ లెవెల్ మెయింటైన్ అవ్వకపోతే అదర్వైజ్ పంపుల్లో ఎయిర్ లాగిందంటే పంపు డ్యామేజ్ అవుతుంది కాబట్టి సర్జిపూల్ మస్ట్ అండ్ షుడ్, అందుకే సర్జిపూల్ పెడతాం అండర్ గ్రౌండ్ లో.
From the surge pool, water will be regulated through drop tube gates. They will flow past speed breakers, known as the pair nose, at the lowest level of the pump house.
వన్స్ మనం సర్జిపూల్ దగ్గర ఉండే గేటు పైకెత్తిన తర్వాత ఆ బికాజ్ ఆఫ్ వెలాసిటీ దగ్గర 3.5 to 4 meters per second అంత ఫాస్ట్గా వాటర్ వస్తుందండి. ఆ వాటర్ డైరెక్ట్ వెళ్ళి మీకు పంప్ మీద అటాక్ చేస్తే పంప్ మీద డ్యామేజ్. కాబట్టి మేము పీర్ నోస్ అనేది ముందు పెట్టాం, చూసాం కదా, వెయిటికల్ కనిపిస్తుంది కదా, అంటే జస్ట్ లైక్ మన హ్యూమన్ బీయింగ్ నోస్ టైప్ అది. ఆ వాటర్ని అది బైఫర్కేట్ చేస్తుంది, అంటే చీల్స్తుంది అనమాట. 2 పార్టీలను తీసుకొని లోడ్ డైరెక్ట్ దాని మీద వెళ్ళకోకుండా సైడ్లోంచి ద్వారా దాన్ని పంపిస్తుంది.
From the pair nose, water will reach its ultimate destination, the pump caverns. These superstructures will house 7 megapumps, each one weighing nearly 2,400 metric tons, with a mega capacity of 139 megawatts, and lift them to a height of nearly 115 meters to the surface. Nothing so ambitious has ever been built in the world of lift irrigation. Each cavern is designed to be earthquake-proof, safe from explosive gases and geological failures. And they've been calibrated within millimeter precision in order for megapumps to be fitted into them. Megapumps that have made a long journey. Each component, years in the making, traveling to Telangana in parts all the way from BHEL in Bhopal. The service bay of Package 8. For the last few days, teams here have been reassembling parts of the pump motor according to the designs.
All the dimensional checks, quality checks are being done at the service bay. When the assembly which is being done at the service bay is complete, then we lower that assembly to the pit.
On assignment from BHEL, it's Jitendra Karki's job to make sure that all goes according to plan.
Challenge is that this is a very unique thing, basically supplying the world highest capacity pump, 139 megawatt. Never have been such a huge capacity pump elsewhere been installed or commissioned.
The most crucial pieces of these record-breaking motors are the stator and rotor. Teams have been working around the clock to put them together. There is only one way to find out if they work: by turning on the switch. It's not the outcome engineers wanted. Excessive moisture has caused the stator to malfunction. It's a crushing setback in an already tight deadline.
We have to seek the result actually, because we have to, with a very compressed time schedule, we have to complete at any cost basically. And any delay basically will affect us and other who are the partners of this scheme.
There's trouble in the tunnels too. a section has collapsed and teams have rushed in to fix it.
డైలీ మా విజిట్స్లో నేను నోటీస్ చేసింది ఏంటంటే లూజ్ ఫాల్ అయింది. సో వన్స్ లూజ్ ఫాల్ అయిన తర్వాత డెఫినెట్గా లోపల క్యావిటీ అనేది ఫామ్ అవుతుంది. సో ఆ క్యావిటీని మనం ఫిలప్ చేయకుండా మనం అడ్వాన్స్ కాలేము దీనికి. సో అందుకని చెప్పి మొత్తం అంతా కూడా టోటల్గా మన సిమెంట్ గ్రౌటింగ్ పెట్టి మొత్తం అంతా అది ఆ వాయిడ్స్ని మొత్తం ఫిలప్ చేసి మళ్ళీ ఎస్కలేషన్ ద్వారా మళ్ళీ 1 మీటర్ అడ్వాన్స్ అయ్యి ముందుకు పోవాలనుకుంటున్నాం. విత్ ఇన్ ద టైం పీరియడ్లో పనిచేసేదానికి పూర్తిగా కృషి చేస్తూ ఉన్నాం. 24 hours మన వర్క్లోనే ఉన్నాం.
But working underground is not easy. It takes guts of steel to persevere.
ఆల్మోస్ట్ ఆల్ సర్ఫేస్ మీద నుంచి 100 meters బిలో ఉన్నాం మనం. అంటే అరౌండ్ 330 feet కింద ఉన్నాం బాటంలో. సో హ్యూమిడిటీ ఎక్కువ. మనం ఆల్రెడీ వెంటిలేషన్ మనం ఇక్కడికి ఇచ్చేస్తున్నా కూడా సప్లై చేస్తున్నా కూడా ఇంత హ్యూమిడిటీ మనకు వస్తూ ఉంది. ఇది ఒక మెయిన్ ఛాలెంజింగ్.
These dark and dank tunnels can test even the strongest of bodies and minds.
I have a claustrophobia. When it is a closed places, I can't stay for more longer duration. I have consulted one of my best doctor who is available here. They have given a good counseling. With the great help of that, I have also personally motivated myself, because this is a lifetime achievement, lifetime challenges which I want to see. I want to supervise. I want to motivate my people.
Work at each Kaleswaram project site carries on at breakneck speed. But there are times when even the most efficient schedules must bow before Mother Nature. The skies crack open. The region receives some of the highest rainfall in recent memory. It floods Link 1's Sundila site, halting all construction. It's a massive blow. The pump house is entirely flooded.
Flood water valna huge quantity water valna first 1 week actually we are in shock. Actually how to remove this water, this much of quantity of water, huge pumps anni kuda arrange cheskoni 15 days lo adu clear chesamu.
Sundila was already playing catch up, having started construction a few months behind other locations. Meeting the 18-month deadline just got even harder. But the show must go on. All across the Kaleswaram project, schedules are racing towards completion. As an auspicious ritual, coconuts are cracked with each milestone. Progress at the all-important hydraulically operated pump discharge or HOPD valves. Each one weighs anywhere between 50 to 60 tons.
Ali, maybe the speed we need to adjust. The speed, I think we need to adjust. But it's okay.
It's their job to make sure that water flows out from the pumps and doesn't splash back. Jackie Zhang is here from China. He does critically important checks on machines his company has built.
Actually, I'm very happy at the progress of this Kaleswaram project. It's very fast. So all the supplies like the motor pumps, all the civil work and our valve also deliver on time. And also the site work is very fast. We are very happy.
All is well at Anaram. Back at Package 8, it's taken 30 days and a lot of sweat and toil to bring things back on track. D-Day for Package 18, that's been working to repair one of the 139 megawatt pumps, which had stalled due to excessive moisture.
high voltage tester, one of the bar got failed. So we replaced the bar and put the machine in the dryout. We have lowered the stator day before yesterday actually. So today we are planning to lower the rotor.
The parts have been tested successfully and given the green light. Time to be lowered into the pump cavern, piece by piece. There's a lot on the line. Installation happens layer by layer, like an onion. The shaft forms the axis. Everything else must align with it, down to millimeter precision.
अभी शाफ्ट अलाइनमेंट कर रहे हैं, टॉप शाफ्ट, बॉटम शाफ्ट, क्योंकि इसमें 3 शाफ्ट है, पंप शाफ्ट अलग है और फिर बॉटम शाफ्ट अलग है, टॉप शाफ्ट अलग है। इन तीनों को हमें एक ही एक्सिस में लाना पड़ता है। अगर एक्सिस डिफरेंस रहेगा तो मोटर बबल करेगा, आउट घूमेगा, तो हमारे बेरिंग्स का टेम्परेचर भी बढ़ सकता है, वाइब्रेशन भी आ सकता है, तो वो बहुत इंपॉर्टेंट है। अगर इसको अलाइन नहीं करेगा तो बाद में मोटर में प्रॉब्लम आ सकता है। तो उसको वर्टिकली चेक करके प्रॉपरली अलाइन करके हम फिक्स करते हैं ताकि मशीन स्मूथली चले।
Multiple checks later, the installation is successful. Every part is secured in its rightful place. There's huge sighs of relief all around. Over at Sundilla, too, there is cause for cheer. Teams have worked day and night to make up for time lost in the floods. They have done so without a single compromise on engineering or construction standards.
As it is control station and control station of that entire pump house, we can say it is the heart of the pump house project. So from here we can control inflow, outflow, total we can monitoring each and everything from here only.
Throughout the Kaleswaram project, commitment to timelines, quality and safety remain uncompromising. Every aspect of Link 1's pump houses is monitored and reviewed.
ప్రతి పంపు మోటార్లోనూ మీకు ఆపరేటింగ్ చేస్తున్నప్పుడు ఉన్న ఇష్యూస్ అన్ని కూడా డాక్యుమెంట్ చేయండి.
No stone is left unturned. After all, lifting the river might be a mammoth undertaking, but it's the tiniest details that matter. Critical tests, with and without high-volume water flow, continue at each barrage, pump house, pipeline and tunnel. As every site turns in successful results, the day for commissioning Link 1's pump houses draws closer. So far, there are no weak links. But will they work in unison and make a perfect beginning for Kaleswaram project? The pieces of this mega project are coming together. From Medigada to Anaram, Sundilla to Sripada Yelampalli, down the tunnels to Package 8. Now it's time for the pieces to work as one. The top brass is on the ground to oversee last-minute preparations in Link 1 of the Kaleswaram project.
Tomorrow 12:03 is the switching on time for the, at least for the one pump. We are planning to initiate the first pump commissioning. For any commissioning we need to have some protocol system. That protocol system, all our sub-vendors are here, they are attending, they are checking each and every component.
It's a teamwork amongst all the various system suppliers. All those systems have to be checked and all the interfaces between the individual suppliers have to be checked that they really work. So that is always a tricky thing when it comes to the commissioning.
There can be no missing links in the chain. Everything must work like clockwork. the hopes of thousands of workers and engineers are pinned on everything going off without a hitch.
This project is going to cater 45 lakh acres, which is a huge area, and it will be giving water for 2 crops. So that means 90 lakh acres will be producing gold out of the land. That's the dream of this project. I hope, I pray to God, we are closer to our goal.
For the first time ever, the river will be let into Kaleswaram project pump houses. At Medigada, the pumps are turned on. It's the point of no return. At the delivery canal, all eyes are on the outlet. Has the Kaleswaram project successfully lifted the Godavari River?
The baby has come out. Of course, the person who feels only could able to express that. But I really faced that happy moments by during the commissioning stage.
In that entire 2 years execution, once water reaches at the delivery point, I felt so happy, and that is the most memorable moments for me.
During execution, a lot of enthusiasm was there. I wanted to see the river to go in reverse direction. Really, it's a proud to be part of this project. And moreover, I'm serving my motherland.
Pumps will be turned on at each site along the Kaleswaram project in the due course of the Godavari water reaching the pump houses, driving the river onwards through a network of pipelines, gravity canals, and tunnels, and boosted upwards from underground pump houses back to surface.
పనికి ప్రతిఫలంగా ఈరోజు వాటర్ వచ్చి మేమంతా చాలా హ్యాపీ ఫీల్ అవుతున్నాం. ఇంత ప్రెస్టీజియస్ ప్రాజెక్ట్లో మేము పార్ట్ అయినందుకు వీఆర్ ఫీలింగ్ వెరీ హ్యాపీ అండ్ ద సేమ్ వెరీ ప్రౌడ్ ఆఫ్ దిస్.
We were quite elated to have this Kaleswaram order to execute.
Each site has been rechristened.
ఈ ప్రాజెక్ట్ అంత ఛాలెంజింగ్ జాబ్ కానీ ఈ ప్రాజెక్ట్ అంత హ్యాపీ మూమెంట్స్ సాటిస్ఫాక్షన్ కానీ ఏ ప్రాజెక్ట్లో దొరకదు. ఎందుకంటే మళ్ళీ వెనక్కి చూసుకుంటే లైఫ్లో ఇంత పెద్ద ప్రాజెక్ట్ జీవితంలో మళ్ళీ వస్తుందని అనుకోవట్లేదు. ఈ ప్రాజెక్ట్లో భాగమైనందుకు నేను చాలా చాలా హ్యాపీగా ఫీల్ అవుతున్నాను. భగవంతుడికి ధన్యవాదాలు.
నా ఒక్కడి కృషిగా సార్ కొన్ని వందల మంది కృషి ఇక్కడ ఉన్నది. ప్రతి ఒక్కటి చిన్న నుంచి పెద్ద వరకు అందరూ ఈ రోజుతోటి చాలా ఫుల్ హ్యాపీగా ఉన్నారు ఈ సక్సెస్ అయినందుకు.
Marvelous. You can't explain words.
The Godavari will now fulfill her destiny, traveling from barrage to barrage, pump house to pump house, and reservoir to reservoir, at times going in reverse of its own course, at others letting gravity do the work. At each step, it will break records and bring relief, lifted by an extraordinary feat of engineering.